Hi, I'm Peter McNulty from the Math Department. This year I was on the I team teaching calculus using the iPad. One of the most useful apps that I came across was called Educreations. It's a whiteboard app that allows you to include a voiceover recorded with your written explanation. With the help of the other members of the I team, I found that it was an even better tool for assessment. So we made a short video to help you understand this app, and maybe you can use it next year. We've included some examples of how the app was used in math, but also in social studies, and even a student-made Educreations tutorial so that you can see how it's used as an assessment tool. I hope you find it useful. Thanks for watching. To download Educreations, visit the App Store on your iPad. Here you want to type in Educreation in the search field on the upper right, and you'll find Educreations. Download it using your password, and it'll be on your iPad. After a brief tutorial, you'll be able to start using it. The tutorial is really going to run you through an interface which is very similar to some of the note-taking apps that we've been working with, like Notability in Session 1. All of your color selections are right there with the boxes on the left-hand side of the menu bar. Before you start doing any kind of Educreation tutorial, you have to be sure to press the recording button. When you press it once, you begin recording. If you press it again, you pause the recording. When you're completed with your tutorial, then of course you press the Done button. If you want to type in text, press the capital letter T, and a text box will appear, which, using the finger, you can drag anywhere onto the whiteboard. If you want to import a picture, either from your camera roll or from the internet or from Dropbox, choose the icon of the little mountains with the sun above it. Of course you're going to make mistakes, and so for that we use the undo button, or at times the redo button, and for really big mistakes, the eraser. Once you finish your tutorial, press the Done button in the upper left. You'll be asked to name your tutorial, and then you can choose who can view this lesson. I've typically opened it to the public, though of course you can just make it a private lesson and send the link individually to people that you want to see it or to your students. The final step was done by using the arrow, which is in the upper right-hand corner. When you depress that, you get a series of choices of where you want to share your tutorial. It can be to Facebook or Twitter, to email, which is what I've typically done, or you can copy the link. I've usually sent the tutorial to myself in an email, copied the link, and posted that on iTunes U. After that, you're ready to share this tutorial with your students. Mike Field from the History Department gave us a student-made tutorial which discusses the Volstead Act. From this, she uploaded some images probably from the internet, both of a graph and some images that she may have even taken herself. But listening to Liz's description of the Volstead Act and what she's learned about Al Capone really helps you to get an insight about how comfortable she is with this subject, which is different than what you might gain from a paper or some other means of assessment.
Alright, so we start off this era with the Volstead Act, which is basically the National Prohibition Act, and it was an act to carry out the 18th Amendment, so it regulated sale and it prohibits drinking during the 1920s. During the 1920s, there was actually a rise in crime, even though they tried to prohibit alcohol. So gangs were on the rise, and they took over the production of alcohol through speakeasies and bootleggers. Bootleggers were people that sold alcohol, and speakeasies were places that had alcohol, and they were like hangouts. Al Capone was one of them, was one of the main people, obviously, and he and many other gangs often killed people who tried to enforce the law. So like policemen who tried to break up speakeasies and such. So during this time, as you can tell, there was a big rise, and so obviously their goal wasn't very successful. And you can also see some rises over here as well. So a famous place during this time was Al Capone's home, which was on 7244 Prairie Ave, Chicago. And so this is what it looked like, during the 1920s. It was built in actually 1914, and the Capone family lived there.
The last example comes from my own calculus class. Denise DeMosco had given me the idea to use Educreations as an assessment. And so rather than give a test on a really difficult topic called optimization, I used Educreations and gave the students some pretty challenging problems that they had to respond to in an Educreation tutorial. What I gained was not an understanding of just whether they could get to the right answer, but I had a much better sense of the depth of their knowledge and their ability to handle non-routine problems. So not only were the problems that I gave them more challenging than I typically would put on a test, but I was able to get a much better idea of the level of their understanding. So please, bear with the calculus for a minute, and you can hear Leah Hanhart go through her problem and how she handles kind of the non-standard aspects of the problem. The fact that the lid and the bottom of this can she's talking about are twice the cost of the rest of the materials for the can.
Number 9 says that cardboard juice cans are constructed with cardboard sides and metal tops and bottoms. The typical can holds 12 fluid ounces. The metal costs twice as much per square inch as the cardboard. So what dimensions of the can will minimize the cost? So first we're going to create a diagram. This is the can with the metal tops, bottoms, and the cardboard sides. And it says that the typical can holds 12 fluid ounces. So that is your constraint equation. Since 12 is a volume, we set 12 equal to pi r squared h, which is the volume of a cylinder. Then, because the problem is looking for what dimensions will minimize the cost, your optimization equation is the surface area. So area equals, and since the metal tops and bottoms cost twice as much as the cardboard sides, you multiply the area at the top and bottom times 2. So you get 2 times 2 pi r squared plus the surface area of the cardboard sides, which is 2 pi r h.